This is A level applied to new Edexcel. And chapter 2, which is conditional probability, mixed exercise 2. I'll show you the solutions of EMP. And if it is too repetitive, then I will skip some. Let's start from number 2. JKL 3 events. And they are like this, and K and L independent, and L J mutually exclusive. Okay, then we can make the diagram like this. J and K and L, which is mutually exclusive. They have no intersection. So now we can make it. So this is 0.1 and J is 0.15 and 0.35 and L is 0. No, actually there is no evidence there. So now K and L are independent, so we can make it K and L as it is independent. So this is the product of K and L. So K is 0.45, 0.15. Let me bring my calculator. So 0.45 times 0.15, 0.0675. So L could be 0.15 minus 0.0675, 0.0825, and K is 0.45 minus 0.1 minus 0.0675. So this is like a pure K, 0.2825. So now, and we can find the exterior part. So 1 minus 0.25 minus, let me make 0.45 minus 0.15 minus 0.0825. So here 0.3175. So now we can make it J or K all together. Actually, this is easy. J plus K minus intersection. So 0.7 minus 0.6. So out of J and out of L. This is out of J and out of K. Sorry. Out of K. Oh. So if you find the intersection of that, it is out of J or K. So now we can find this is, oh, okay, sorry, J and J complement and L complement. So anyway, it's gonna be same. What I'm saying, it is out of J or L. So J or L, since J and L is mutually exclusive, J or L is 0.4. So this is 1 minus 0.4. This is probability of J or L. So this is 0.6. And this is conditional probability out of K. So J out of K, J and K, probability J and K out of probability K. J and K is 0.1, probability of K is 0.45. So this is 0.222. And IV. This is probability of here. Probability of K and J complement N L complement over probability J complement N L complement. So this is 0.6. So out of J and L, N complement at the intersection of K, which is 0.2825. So 0.2825 divided by 0.6, 0.471. No, I mean, yeah, 471 for the third significant figure. And the next one. 60 students in high school, 6th form, 35 French, 45 Spanish, 27 both, and random, only one. Okay, so out of 60, so French, Spanish, 27 here, 8 here, this is 18, yep, 30, 45. So all together, 45, 50, here is 7. So studies only one project. This is probability. So out of 60, this is 26 out of 60. And French given Spanish, probability. French given Spanish. So out of Spanish altogether, 45. The students who study French is 27. And Spanish given French, out of French 35 students, there are 27 students who study also Spanish, and it's found that 75% of students who study just French wear glasses, and half of the students, okay, so just French 8, so 75% out of 8 is 6 students. So wear glasses, like 6 comes from 8, so 0.75. So wear glasses, and half of the students who study just Spanish, which is 18, and half is 9, wear glasses. Find the probability the student chosen at random studies one languages and wear glasses. So probability. One languages and glasses. So one language and wear glasses is just 15 out of 60. And E, wear glasses given, studied one language. So this is glasses given one language. Who studies one language is 26. Out of there, we have 15 students who is wearing the glasses. So that's it. Oh, I just found number C was do not study French. I'm sorry. So do not study French is 25, and study Spanish is 18. So 25, 18. And okay. Number 4. Bag contains 6 red balls, 9 green balls. Color, okay. Second ball. So ball placed to one side means no replacement. So tree diagram. So red, green, red, green, red, green. So first, 6 out of 15, 9 out of 15. So 5 out of 14, 9 out of 14. 6 out of 14, 8 out of 14. So this is a full tree diagram. So find the probability that both green. So green and green. So means here. So 9 out of 15 times 8 of 14. And different colors. First green, second red, or first red, second green. So this one, 9 out of 15 times 6 out of 14 plus 6 out of 15 times 9 out of 14. You will find the answer. 4 the balls are drawn from the bag and not replace it. Okay, find the probability that third ball is red. Okay, so actually because now we are considering only the ball which is drawn in third time, so we don't much care about what was the first and second ball. So now we can say the first ball, any of the first ball, and second ball, any of the second ball, and the third ball could be red. Okay, sorry. It's not replace it. Again, it is not replace it. So red, 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 green, red, green, red, red, green, green, red. So red, red, red. I'll make it from here, like sequentially. Then 6 out of 15 times 5 out of 14 times, now we have 4 out of 13 plus 6 out of 15 times 9 out of 14 times 5 out of 13 plus 9 out of 15 times 6 out of 14 times we have 5 out of 13 plus 9 out of 15 times 8 out of 14 times 6 out of 13. This will be the answer. And it takes just 4 selections to get 4 green balls. So the first, like a green, 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 green. This is how we want to know. So this one is the first green, 6 out of 15. No, sorry, 9 out of 15. And 8 out of 14. 7 out of 13, 6 out of 12. Number 5, tennis match. Anne wins the first set against Colleen, 0.7. The first set, she wins the second set, okay. Loses the first set, okay. So match is 1, one player wins 2 sets. Probability over after 2 sets, okay. The first set. In second set, we have 2 sets. So first set, who wins? And Colleen. Second set, and Colleen, and Colleen. So N wins the first set, 0.7, which means 0.3. And wins the first set. The second set, 0.8, 0.2. If she loses, then 0.4. and 0.6. And A, find the probability over after 2 sets. So one player wins 2 sets. So this one or this one. So probability of N, or probability of Colleen and Colleen. This is what we want to know. So this one, 0.7, 0.8 plus 0.3, 0.6. Number B. Find the probability N wins given the game is over after 2 sets. Okay, so N given, finishes over after 2 sets. Game So now, just now we may find it 56, 18, 74, so 0.74 and 0.5. 5 or 6. So yeah, you will find it 56 out of 74. And number C. Game tied at 1 settle. Tiebreaker is played and okay, and winning it is 0.55. So here and here. So n colon 0.55, 0.45, 0.55, 0.45. So find the probability n winning the interior match. So the n can win probability n plus n colon n plus colon n. So this is how she can win. So 0.7, 0.8 plus 0.7, 0.2, 0.55 plus 0.3, 0.4, 0.55. Color of the pose of 75 kittens are recorded. Cute. 26 all black, 14 all white, 15 combination. One kitten is chosen at random, neither white nor black pose. Okay, so black and white. So okay, maybe not like this. Neither black or white. So 1 minus 75, 26, 14, 15. The combination of black and white pose given some black pose. So black and white, any black. Then black and white is 15, and any black is 15 plus 26. And number C. Two chosen, both all black pose, both some white pose. Okay, so first we can make it. If we find that first one is out of 75, we may find 26, and out of 74 we may find 25. So some white pose. So WW, like the small letter is black and white combination, then W and W. So in this case, actually any white altogether is 14 plus 15, which is 29. So 29 out of 75 plus 28 out of 74. I think this can be the easy answer. Two event A and B, okay, and independent, which means B is 0.3 as P A and B is PA and PB. 0.12 is 0.4 times PB. A complement and B complement, and out of A and out of B, and the intersection is out of A or B. So out of A or B means we need to know A and B, A or B. So A or B is A plus B minus A and B, because A and B is like overlapped, so you may calculate twice just with this. So we need to subtract once. So 0 0.7, 0 0.58. So this one, 1 minus 0 0.58 means 0 0.32. 42. Okay. So number C. Venn diagram, mutually exclusive. Okay. So A, B, C, 0 0.1. A and B 0.12, so 0.28. B was 0.3, so 0.08, and C 0.3. So altogether 0.688, 0.12. So find C, probability of C, the numerator is B and C. So B and C is 0.1 out of 0.4, 0.25. And this one, outside of B, complement of B, or C. So actually, or C, like this. So out of B, including all part of C. So here, and intersection of A. So this one is 0.28. That's it. Oops. And the next one. Number 8. For maths, score first 26 and B first at 0.35. Do not add up to when maybe tie. Two team maybe tight. And probability A scores first and wins the match is 0.48. Okay. No, actually I didn't understand properly. So A scores, maybe there will be no goals. There may be no score match. A score first and wins the match is 0.48. Does not win the match. Okay, so here the first goal. A, B, none. So A is 0.6, 0.35, 0.05. And win, lose. So here, A win 0.48, 0.52. Find the probability A score first and does not win the match. So like this. So 0.6 times 0.52. And if B score first, A will win 0.3, which means B lose. Maybe this is better. I'll make it like win A, B, A, B. So 0.3, 0.7. So if B score first, A wins 0.3. So given A won the match. So probability A did not score first. So A first scored no, but A won. So probability of A first score was by B and A1, and probability of A1. So 0.35 times A1, 0.3 over 0.6 times 0.48 plus 0.35 times 0.3. This is all the case of all the cases of team A1. So yeah, that's it.